So good morning friends, I welcome you all to my YouTube channel. So we all know that we have been discussing about determinants. Also we have started the second exercise of the determinant and we have solved up to certain problems and I have given some problems as homework. Right? So we have solved 11 problems. In that first part I have solved, second part I have given as homework. Also I have given 12, 13, 14 as homework for you people. I hope you have got the answers. So if you have not got the answers, you can cross verify with this. 11th part, second one is as usual. Right? So 12th one we will start here. So if you have got the answer, it is well and good. If you have not got the answer, if you are struggling with the procedure, then you can listen to the session and then you will get back to the answers. Okay? So fine. So let's see what is the problem number 12. So here they have given a 3 cross 3 determinant as usual and they have asked to prove it as 1 minus x cube into 1 minus x cube the whole square. Right? So how to do this? Let's see. What is our LHS? 1 x square 1 x square 1. Right? So as I said, if you get any, if the determinant is such that if you add all the 3 rows or 3 column, you get the same result, then you have to go ahead with the addition of either rows or column. Okay? So let's go through an operation. R1 changes to R1 plus R2 plus R3. So let R1 change to R1 plus R2 plus R3. So what happens? LHS R1 is changing to R1 plus R2 plus R3. 1 plus x square. Here also 1 plus x square. 1 plus x square. So here x square 1 x square 1. Okay, so now I can take 1 plus x square outside as a common. One remains. So here x square 1 x square 1. Okay, fine. So now as usual we can go for the column operation. C2 changes to C2 minus C1 and C3 changes to C3 minus C1. Then our LHS becomes, C1 is not changing, keep it as it is, 1x square. Okay, C2 is changing as C2 minus C1. 1 minus 1 is 0. This will be 1 minus x square. Then x square minus x. So here also 1 minus 1 0. X minus x square. Then 1 minus x. Okay. Now expanding through first row. This will be, right, see, expanding through first row. So first row, what we are having here, 1 0 0. So this is plus, so that will be 1, sorry, into 1 plus x square. So 1 plus x square into 1 into, what is this determinant? 1 minus x square minus x square minus, sorry, x minus x square, right? So x square minus x, 1 minus x. Okay, so this can be written as 1 plus x square into 1 minus x square can be written as 1 plus x into 1 minus x. 1 plus x into 1 minus x. And here if I take x common, 1 minus x. Here if I take x common, I will get x minus 1. So instead of taking x common, I will take minus x common. So if I take minus x common, so what remains? 1 minus x. So now if you multiply minus x into 1, minus x into minus x plus x square, you will get back the same value. Okay. And here 1 minus x as it is. Okay. So take this one. 1 plus x square. 1 minus x common from this row and this row also. So it becomes 1 minus x the whole square. So what remains here? 1 plus x minus x 1. Okay. 1 plus x minus x and 1. So this will be 1 plus x square into 1 minus x the whole square into 1 plus x into 1 plus x minus x into x. Okay, so this is 1 plus x square, okay, into 1 minus x square. Okay, so this is what? 1 plus x, right, plus x square, right? 1 plus x square, right? Sorry, this is 1 minus x the whole square. Now this can be written as 1 plus x square the whole square into 1 minus x the whole square, right? 1 plus x square into 1 plus x square. So it is 1 plus x the whole x square the whole square into 1 minus x square as it is. This can be written as 1 plus x square into 1 minus x whole square. Square and square is there, you can take for common, right? So now if I expand this, what will I get? 1 into 1 into minus x, right? X into 1 plus x, right? X into minus x square, x square into 1 plus x square into minus x cube, right? So plus x minus x cancels, plus x square minus x square will cancel, right? This one will be there inside the square. So what will we get? 1 minus x cube the whole square. 1 minus x cube the whole square. So I hope you have understood this one. It is very simple. Transformations remain same, but simplification is little bit lengthier here, but remaining everything is as same as the previous problems. So now what you need to do is, as usual, pause the video and make a note of this. So students, I hope you have understood that one. So let's proceed with the next problem. Right, there is 13th one. So it is what? We should prove 1 minus a square plus minus 1 plus a square minus b square, 2ab minus 2b, 2ab, 1 minus a square plus b square, 2a, 2b minus 2a, 1 minus a square minus b square as equal to 1 plus a square plus b square the whole cube. Here the terms are not same, so it is not possible to add all rows or all columns. So we should make some changes, we should apply some transformations such that in any one row or column we get same elements, so that it can be taken out as common. Okay. So now let's see how it will be possible. what is our LHS? 1 plus a square minus b square. This is 2ab. This is minus 2b. This is 2ab. 1 minus a square plus b square. This is 2a. This is 2b. This is minus 2a. 1 minus a square minus b square. So now what we need to do is, as I said, we should apply certain transformations which will make us possible to take something common out of each and every any one of the row or any one of the column. So now observe here carefully. What I am going to do is C1 changes to C1 minus BC3. C1 is going to change as C1 minus B into C3, whereas C2 is changing as C2 plus A into C3. Right? C1 changes as C1 minus B into C3 and C2 changes as C2 minus A into C3. C2 plus A into C3. So why is that? Why I have done? Because something I should take common. What should be that something? That should be 1 plus a square plus b square. So I should apply certain transformations which will make entire row or column as 1 plus a square plus b square. Any row or any column as 1 plus a square plus b square. So to get this one, I am applying this. So let us see what is going to happen. C1 is changing to C1 minus BC3. What is C1? 1 plus a square minus b square. C1 minus b into, what is C3? Minus 2b. And here 2ab minus C3 is what? So b into, what is C3? 2a. And this is 2b minus b into 1 minus a square minus b square. This was about C1. So what happens to C2? C2 changes to C2 plus AC3. Right? 2ab plus a into minus 2b. And here 1 minus a square plus b square plus a into 2a. And here minus 2a plus a into 1 minus a square minus b square. Right? So this is our determinant. Right? After applying the transformation. Sorry, one more row we have left out. One more column. That minus 2b, 2a, 1 minus a square minus b square as it is. You write it. Okay. So now what happens here? 1 minus a square minus b square, right? Minus b into minus 2b plus 2b square. Okay. And here b into 2a is 2ab. So 2ab cancels. So 0 remains. And here see, I will take b common. So what remains if I take b common? 2 minus 1 plus a square plus b square. And here 2ab minus 2ab. So this cancels. So what remains here? This becomes 0 and this will be 1 minus a square plus b square plus 2a square. And this one, if I take a common, sorry, minus a common if I take, so what remains? Or if I take a common, minus 2, right, plus 1 minus a square minus b square. This is if I take what is common? A. If I take minus a common, this becomes 2, this becomes minus, plus and plus, right? And here as usual minus 2b, 2a, 1 minus a square minus b square. That is our determinant. Okay, which will be equal to C. 1 minus a, sorry, this is 1 plus a square, right? So 1 plus a square minus b square plus 2b square. Minus b square plus 2b square is plus b square. So this becomes as 1 plus a square plus b square, and this is 0 as it is, and here b into, if I simplify this, 2 minus 1 is 1 plus a square plus b square, right? And this is 0. Once again, minus a square plus 2a square will be plus a square. So this will be 1 plus a square plus b square, and minus a common. So what will be this one? 2 minus 1 is 1. 1 plus a square plus b square, and here minus 2b, 2a, and 1 minus a square minus b square. Okay, fine. So in first column I can take 1 plus a square plus b square common, as well in second column also I can take 1 plus a square plus b square as common. So if I take them as common, so what happens? 1 plus a square plus b square from first column and from second column. So it will be square. So what remains here? 1, 0, minus 2b, 0, 1, 2a, and this will be b minus a, 1 minus a square minus b square. Okay, so this will be the value. So now if you simplify this, you are going to get the answer, right? So what we need here? 1 plus a square plus b square. Okay, so there is no option that you can cancel out, right? So expanding through first row, what am I going to get? 1 plus a square plus b square as whole square as it is. Okay, so 1 into what is determinant? Leaving first row and first column, 1, 2a minus a, 1 minus a square minus b square, right? So minus 0 into anything is 0, so plus of minus 2b into, so what remains here? 0, 1b minus a. Okay, if you take 2b, you should leave first row and third column. What determinant comes, that should write. So this is 1 plus a square plus b square the whole square. What is this determinant? If I calculate this, it will be 1 minus a square minus b square minus a into, sorry, minus of minus a into 2a. Okay, then minus 2b into 0 into 0, 0 into anything is 0 minus b. Okay, so this is 1 plus a square plus b square the whole square, 1 minus a square minus b square. This is minus a square, this becomes plus a square, right, plus 2b square. So this is 2a square. 1 minus a square minus b square, right? Minus a into 2a is minus 2a square, into minus is plus 2a square, right? So this is 1 plus a square plus b square the whole square, right? So 1 is there, plus a square, sorry, minus a square plus 2a square, 1 as it is, plus a square. 2a square minus a square is a square. 2b square minus b square is plus b square. Okay, so now I can write this as 1 plus a square plus b square the whole cube. So this is what which was required. So we have proved it already. So you pause the video and make a note of this. So friends, I hope you got the answer for the previous one. So let's continue with the 14th one. Previous one we have solved very deliberately. I hope you have understood the answer for that. So let's proceed with the next one. So it's the 14th question. So here also we need to prove some determinant as equal to LHS as equal to RHS. So let's see how it can be done. Okay. So what is our LHS here? It is a square plus 1 AB AC AB B square plus 1 BC CA CB C square plus 1. Okay, so now what to do with this? Okay, we cannot add. If we add, we are not going to get 1 plus a square plus b square. So we should do some transformation here so that we will be in a position to get 1 plus a square plus b square here. So now what I will do, multiplying C1, C2, C3 by A, B, C respectively and dividing the determinant by A into B into C. Right? So what have I done here? So for C1, C2, C3, for C1 I am multiplying A, for C2 I am multiplying B, and for C3 I am multiplying C. So as I am multiplying A, B and C, I should divide A, B, C, so that I am doing, right? So I am dividing A determinant by A, B, C. Okay? So what happens here? So LHS becomes equal to 1 upon ABC into multiplying A to first column, A square plus 1, A square B, right, CA square, and B to second column, AB square, B into B square plus 1, CB square, and here C if I multiply, it will be AC square, then BC square, then C into C square plus 1. Okay, so I have multiplied A to first column, B to second column, and C to third column. So and also as I multiply I should divide, so I have divided the determinant by A into B into C. This you can see here. Okay, so now in first row you can see A and A is common, so take A common from the first row. In second row B is common, so take out B. In third row C is common, so take out C. Okay, so in first row we have A common, so I am taking it out of the determinant. In second row I am having B common, so that also I will take it out of the determinant. And in third row I am having C common, so that also I will take it out from the determinant. So it will be like ABC divided by ABC. A from the first row, B from the second row, and C from the third row, and 1 upon ABC as usual it is there. So if A comes out, what remains? A square plus 1, right? So here B square and here C square. Here B comes out, what remains? A square and B square plus 1, and here C square. And here C comes out, what remains? A square, right? Okay, and here B square and here C square. Okay, is that fine? Okay, so from first row I have taken A common, so what is left out? Okay, so if I take A common, so A square plus 1, B square and C square. If I take B common, so what remains here? If I take b common, a square, b square plus 1 and c square, and here if I take, this is c square plus 1. So if I take, right, c common here, so it will be a square, b square and c square plus 1. Okay, this will be our determinant value. This becomes our determinant. So next, let's simplify this one. So let us check. So ABC and ABC cancels. So LHS will be equal to a square plus 1, b square, c square, a square, b square plus 1, c square, a square, b square, c square plus 1. Okay, so now you can see I can add either row or column, so then I will get the same entries as 1 plus a square plus b square plus c square, right? Row 1 changes to row 1 plus row 2 plus row 3, right? So you can add row 1 or you can make column also. That also will give you the same result, right? C1 changes to C1 plus C2 plus C3. So this becomes equal to what? A square plus 1 plus b square plus c square. So a square plus b square plus c square plus 1. Here a square plus b square plus c square plus 1. And here a square plus b square plus c square plus 1. Here b square plus 1, b square, c square, c square, c square plus 1. Okay, so this is how the determinant comes. Now take 1 plus a square plus b square plus c square common. 1 plus a square plus b square plus c square common if I take. So what remains? 1, 1, 1, b square plus 1, b square, c square, c square, c square plus 1. Okay, so I have 1, 1, 1 here. Now itself I can expand this, right? But still I can make it simple. So by operating the rows, right? Row 2 changes to row 2 minus row 1. Row 3 changes to row 3 minus row 1. So this is 1 plus a square plus b square plus c square. Okay. Here row 1 is not changing. 1 b square c square as it is. Row 2 is changing to row 2 minus row 1. 1 minus 1 is 0. B square plus 1 minus b square. So it is 1. C square minus c square is 0. 1 minus 1 is 0. B square minus b square is 0. C square plus 1 minus c square. It will be 1. So now it is very simple, right? It is very simple to expand. So now expanding it through first column. So what will I get? 1 plus a square plus b square plus c square into 1. First element in the first column is 1. So leaving first row and first column, because this is containing the first row and first column. 1 is contained in first row and first column. So leave that row and column. So what remains? 1, 0, 0, 1. Okay. So now 1 plus a square plus b square plus c square into, what is 1 into 1? 1 minus 0. So this can be written as 1 plus a square plus b square plus c square. Right? So that was asked to prove. We have proved it. So now we pause the video and make a note of this. Okay, so that was the previous problem. I hope you have understood the transformations, everything in that. So with that, we'll proceed with the next thing, right? So this will be the last part, right? Actually, this problems you try as homework by yourself. You try it by yourself. You're not getting, so then let me know in the comment box. I'll get back to you. Okay. So what is given here? Let A be the square matrix of order 3 cross 3. So A is a square matrix of order 3 cross 3. Then what is determinant of K into A equal to? Determinant of K into A equal to. So first what they have given, A is given as 3 cross 3 matrix. So what will be determinant of K into A? They have not asked you the determinant of A. They have asked you the determinant of K into A. So first you should find the matrix K into A. Right? They have given you a matrix A which is of order 3 cross 3. Then now you need to find K into A. A matrix K into A. Once you get the matrix K into A, then find its determinant. That means you put it in a determinant pattern. Right? So then you have to find the value of that one, and that will be equal to 1 among these. Okay, so next, so you try that by yourself, but this has to be tried by taking either a general form or by any suitable example. If you take general form, one pattern will be more than enough. As it is general, it will be applicable to everything. So if you take any example, so you should go on proving to many problems so that it will be helpful for you. So you take a general form and prove it. Okay, so next, which of the following is correct? So determinant is a square matrix, determinant is a number associated to a matrix, determinant is a number associated to a square matrix. None of this. So I ask you to solve these two problems by yourself and let me know your answers in the comment box. Okay, so with that we are going to wind up the session. We'll take a leave here. Okay, so take care. Goodbye.